Hello there, I'm going to explain the exercise 1. So, well, they're giving us the densities of the water and gold and the volume is equal to the mass. We're going to get it later, that. And they're asking us for the volume of the water. And now we get this formula, this density equals mass over volume. We clear volume, we change places, so it's going to be volume is equal to the mass over the density of the gold. We already have the density of the gold, and the mass is not here, but they're saying that the volume is equal to the mass. So this is the same as here, and the volume will be equal to this. And now to get the specific weight, they're asking for the specific weight of the gold. And now we have the density is the density of the object times the gravity. So we already have the density of the gold times gravity, and we can have this result. Well, now I'm going to explain the exercise 2. There's a submarine that is submerged 200 meters, and they're asking us to get the pressure gauge, and the force that is applying. So, well, we have the area that they're saying there is 1 times 1.5, the area that they're giving us, and we have this formula. So we have all this data, that is the pressure of the seawater, and the height, and the gravity is always the same. So this is what we get, and then to get the force, we have the same data. With the pressure is equal to force over area, we create area, we pass it to the other side, it's multiplying, and it's going to be the pressure times area, and we can get the force. And now we can get the force of the submarine. Now I'm going to explain the exercise number 3, and for this, they're asking us to get the force that we don't know, and that is the force 2. We need to get the area 1, the area 2, and the force 1. And to get the areas, they are giving us the radius. And they are in meters. We convert to meters, obviously. And now the formula is P times the radius square. Obviously, if it's the area 1, it's with the radius 1. The area 2 with the radius 2. It doesn't need to be the same radius. And now to get the force, we already have the mass, and the gravity is always the same. So it's mass times gravity. We already have the force 1, and now it's only left the force 2. So now we clear area 2 from here to the other side. And it's going to be multiplying, so it's going to be force 1 over area 1 times area 2 is equal to the force 2. We already have all the data, we only use substitute, and we get the force 2. Now, there's going to be the exercise number 4, is the pressure from a hydraulic jack. Now to get this, we need to get the area, and we need to get the force. They're giving us the radius and the mass. And now to get the area, it's always the same, P times radius squared. Now we can get the area, and the force is mass times gravity. We have the mass, we have the gravity always, so it's going to be the mass times gravity. We have these two, and we just substitute in the pressure, and we already have the pressure. That's it. So now there's exercise 5, and they're giving us this data, the weight, the volume, and the air. And now to get the buoyant force is the volume times the density of the object that we want, and the gravity. So we have all this data, and we always substitute, and we get the buoyant force. And now to get they're asking us for the mass of the extra weight, for something to say like that. And we can do it like the buoyant force minus the weight minus the extra weight is going to be equal to 0. And the buoyant force minus the weight equals to the extra weight. And now this is the same, because it's the mass of the extra weight times the gravity is the force. So now we can clear the gravity to the other side, where we have all this data in here, and we can only substitute, and we can get the extra mass that they need. To the exercise number 6, and they're giving us a sphere. So instead of, well, they're giving us a radius. So instead of being an area, it's going to be a volume. The formula is 4 over 3 times the P times the radius cubic. Now we need to get the mass of, it's like the previous exercise, that we need the extra mass. And now they're giving us a mass, we need to get the force, it's going to be mass times gravity as always. And also we need to get the buoyant force. So the buoyant force is going to be the volume that we already have, the density of the air that is acting every time, and the gravity that we already have always. And now we do the same as the previous one. It's going to be like the buoyant force minus the extra force, and it's going to be like this. I use clear. Here it will be like equals to the mass times gravity or force, and I use clear gravity to the other side, and we already have this, this, and this, and we can get the mass. So for this exercise, they're asking us the time from the quantum flow, and now they're giving us the radius and the velocity. And now we already know that the quantum flow is velocity times the area, and now to get the radius is going to be the p times radius square, as always. We can get the area, and the area times the velocity, we have the quantum flow. And now they're asking us to get the time, but to do this, we need to convert into liters over minute. So now we just transform this, this formula, and now we have the final result. This is 225 liters over minute, and now 225 liters is to 1 minute, and now to 20 liters how it's going to be. Now we only use a rule of 3, and it's like in 20 over 2025, 225 liters, and it's going to give us the time. And now for exercise 8, they're asking us again for the quantum flow, and well, they're giving us the height and an area. 18 millimeters square. We convert to meters. It's very easy. This is 1,000 square. So now for the velocity is the square root of 2 times the gravity times height. We have the gravity and the height. We can get it. And now we already have the area. Is the velocity times the area, and we already have the quantum flow. And now for exercise 9, the last one is going to be the quantum flow that we have here, and the velocity is going to be the square root of 2 times gravity times height. We have the height, and they're giving us the time, that is 5 minutes, that is equal to 300 seconds. And now the quantum flow, they're asking us to get the volume and the velocity. We already have the velocity, and now to get the volume, the quantum flow is equal to the volume over time. Now we pass the time to the other side. We already have the quantum flow that they're giving to us, and that is going to be times the time, and we can get the volume.